Let's start our chapter 21, Experimental Design and Separation Techniques. Chapter overview. Focus on experimental design and separation techniques in chemistry. Key learning objectives include understanding experimental design and principles, selecting appropriate experimental methods and apparatus, identify separation techniques, exploring substance identification methods. Experimental planning considerations. Key planning elements: safety assessment, identify potential hazards, develop risk reduction strategies, conduct thorough pre experiment risk analysis. Measurement requirements: determine precise variables to measure, select appropriate measurement tools, establish measurement protocols. Experimental design principles: systematic approach to scientific investigation, careful consideration of equipment selection, variable control, measurement precision, and safety protocols. Separation techniques. So here we have some separation methods and its techniques and its example. So solid separation technique will be solvent base separation. Example: sand and sodium chloride. Second is solid and liquid mixture. Separation technique is filtration, such as copper 2 oxide and water. Then we have solid soluble mixture. Crystallization, the separation technique, and the example is copper 2 sulfate from water. Then we have liquid mixture. Separation technique is distillation. Example: hydrocarbon mixtures. Some specific separation techniques. Number 1, distillation. It separates mixture based on different boiling points. Types: simple distillation, fractional distillation. Then we have water purification methods. Here we have solar distillation, uses solar energy. Simple black bottomed containers, effective for small scale water production. Then we have desalination, remove salt and minerals. Methods are distillation, membrane filtration, or reverse osmosis. High energy requirement and environmental consideration. Then we have personal water filtration. Here we have microtube filter system, removes particles and microbes, portable solution for clean water access. All right. Then we have substance purity analysis, melting point analysis, purity indicators. Pure substances melt at specific temperatures. Impurities cause lower melting point, broader melting temperature range. Melting point measurement techniques: digital meters, electrically heated apparatus, capillary tube method, observation through magnifying glass. Some examples of melting points are pure water 0 degree centigrade, pure copper 1085 degree centigrade, pure aspirin 135 degree centigrade, and pure oxygen minus 218.8 degree centigrade. Some key terminologies to remember and to learn: pure substance, single chemical element or a compound with definite melting and boiling points. Mixture, multiple substances not chemically combined, separable by physical methods. All right, now we have experimental safety consideration. Always wear eye protection, tie back long hairs, use appropriate heating equipment, follow laboratory safety protocols. Some practical skills development: understand separation technique selection, practice precise measurement techniques. develop systematic experimental approach, learn to assess and minimize experimental risk. Now, let's talk about some experimental design and separation techniques. Here we use paper chromatography. Fundamental technique. Core concept, separation method for analyzing complex mixture. This is important, very important for exam perspectives, tested several times. All right, so the core concept here that it's a separation method for analyzing complex mixture, particularly useful for biological molecules like sugar, amino acid, and nucleotide bases. Some practical applications: detecting illegal substances in biological samples, identifying contaminants in food, drinking water. Experimental setup. Key equipment needed: chromatography paper, solvent, water or ethanol, capillary tube, dropping pipette, pencil, ruler, splint or pencil, bulldog clip, hair dryer. Experimental steps. Number 1, preparation. Draw horizontal baseline with pencil. Mark sample locations. Use small sample quantities. Then we have procedure. Suspend paper in solvent. Ensure solvent level below baseline. Allow solvent to travel up paper. Mark solvent front. Dry chromatogram can be used. Then we have some safety consideration. Wear eye protection. Wash hands after handling chemicals. Avoid flammable areas when using ethanol. Locating agents used to highlight colorless substances can be sprayed or applied to paper. Then we have chromatography analysis techniques. Interpreting chromatograms reveals mixture composition, compares sample movement, identifies number of component. Then we have common indicators. Multiple dots indicates mixture. Single dot suggests pure substance. Some advanced consideration: factors affecting separation, solvent polarity, paper composition, sample concentration, and temperature. Experimental variables will be solvent type, paper quality, sample quantity, and environmental conditions. Some practical recommendation and best practices: use minimal sample quantities, ensure precise baseline marking, control solvent height carefully, use consistent technique. Then we have potential errors: baseline drawn in pen, incorrect solvent level, oversaturated samples. Now we have comparative technique table. Paper chromatography purpose is mixture separation, and the key advantage is low cost, and the limitation is limited to small samples. Then we have filtration. The purpose is solid liquid separation. Key advantage is that it is simple process, and the limitation is required particle size difference. Distillation used in liquid separation. Advantage is preciseness. Limitation is energy intensive. Then crystallization. Purpose is solid purification. Key advantage is high purity, and limitation is time consuming. Now we have some laboratory experiment and measurements, measurement precision and accuracy. Some key measurement concept. Number 1, resolution. So resolution is the smallest detectable change in measurement. Balanced resolution examples such as simple balance 0.1 gram and advanced balance 0.001 gram or more. Calibration. Calibration is verifying instrument accuracy using known standards. Measurement tools: temperature measurement. We have Celsius measurement using liquid thermometers, spirit mercury inside. and digital temperature probes. Digital probes can measure from 0.1 degree centigrade to 0.01 degree centigrade. pH measurement methods. Universal indicator paper can be used. Digital pH probe can be used. Digital probes offer higher precision, such as 0.1 or 0.01 pH units. Volume measurement tools. Increasing accuracy. Beaker, least accurate. Measuring cylinder. Volumetric pipette, most accurate for fixed volumes. So, volumetric pipette is the most accurate used for calculating fixed volumes. Then we have burette, most accurate for variable volumes. Then we have gas collection methods, two standard techniques we have. Number one, direct capture in gas syringe. Number two, water displacement in measuring cylinder. Some experimental variables, types of variables. Number one, controlled variable kept constant throughout experiment. Number two, independent variable change during experiment, x-axis. Number three, dependent variable measured result is y-axis. Some example scenario investigating metal reaction rates. Control variables, we have temperature, acid concentration. Independent variable, type of metal. Dependent variable is reaction rate. Now we have error analysis. Types of errors. Number one, random errors. Unpredictable variations reduced by multiple experiment repetitions, removing anomalous data, taking average. Then we have systematic errors, consistent measurement mistakes, example zero errors in equipment. It can be reduced by tearing equipment and subtracting zero error. Some separation techniques, standard separation method used solvent selection, filtration, crystallization, simple distillation, fractional distillation, and chromatography. Learn all the names and their characteristics as discussed above. Filtration process, it separates solid from liquid, uses fine filter paper, prevents solid passage through filter. Then we have chromatography, separates dissolved substances, originally used for colored dye separation, can identify pure substances versus mixture. We have graph plotting guidelines. Key principles, plot independent variables always on x-axis, plot dependent variable always on y-axis, use large scales, label axis with variables and units, use sharp pencil, draw best fit line. Line does not need to pass through all points. Now we have some safety considerations, experimental preparation, assess risk associated with apparatus, chemical substances, take appropriate safety precautions. Some key takeaway here, precision matters in scientific measurements, understand and control experimental variables, recognize, minimize experimental errors, choose appropriate separation techniques, and follow safety protocols. Each of these has been explained in detail before in the same video. There was an explanation about errors, types, how to control, how to reduce them. It's also been discussed what separation techniques can be used and what can be the types of the mixtures that we can have. Similarly, the control variables, dependent, independent variable has also been discussed here, and precision method is also being discussed here. So go through them and learn them for your examination. Now we have crystallization process. Key steps in crystals formation. Evaporation method for obtaining pure crystals. Important techniques. Leave evaporating basin overnight. Allow complete water evaporation. Pat dry crystals between filter papers. Some critical consideration here is filtration. Terminology is filtrate is liquid passing through filter paper. Important. Residue, insoluble material left behind, also very important. Crystal preparation insights, grinding advantages. Breaking rock salt with mortar and pestle increases surface area. So when you grind them, what will happen? We will be needing more surface area. Enhances dissolution and crystallization efficiency, improves overall separation process. Now, some limitation of crystallization process works effectively for crystals, salt crystals. Challenges include may not be suitable for all substances. Iodine in aqueous solution requires alternative extraction methods. Then we have distillation techniques. Simple distillation. Purpose separate solvent from dissolved solid. Some key characteristics include solvent has lower boiling point, more volatile than dissolved solid. Equipment and process essential components distillation flask, water cooled condenser, anti bumping granule. Then we have anti bumping granules function prevent large bubbles formation, enhances safety during boiling process, reduce flask shaking. Then we have distillation applications, practical use seawater desalination, produces drinking water, separating liquid mixtures. Then we have fractional distillation, advanced separation technique used for mixture of miscible liquids. Separate based on different boiling points. Most volatile liquid distills first. Some key terminologies distillate, again important, liquid collected in receiving flask. Desalination, removing dissolved salts from water. Let's talk about comparative table of distillation method. We have method, simple distillation. Purpose is to separate solvent, liquid type solid to liquid, complexity low. Then we have fractional distillation. The purpose is multiple liquid separation. The types are miscible liquids. Complexity is high. With this, we have finished our this lesson. We will continue in our next lesson.